Okay, here we go. So. This class actually makes noise, so you might be uncomfortable here. Like when I ask questions, they answer. Kind of weird. You're probably scared someone from second hour, they're basically all. Like I love them, I think they're great kids, but it's super silent. Yeah, they can sit over there with Tyler and just silent the whole time. Really, who would have thought? I say crap to them all day, every day. I do, and then they look at me like they don't know how to speak. I love them, but man, I know. Is she scary?
No.
Okay. Oh, maybe. Maybe I'm scared. Okay, here we go. Are you ready? Yesterday, we should have got here, but we didn't. So turn to page 11. Well, we'll go back. We're going to balance between 8, 9, and 11 all day long. Okay, yesterday I taught you a little saying that most of you will forget. Stay is one of them. Away is another one. Add is one. Add away. Add a boy. Sorry, girl. Add away. Take. Follow all my process. And you can end up all the way honoring you as a teacher. Oh, I saw you. Okay, here we go. The saying I taught you is add away, take, I stay. So here we go. Oops, this correct. We're going to do a ton of homework together today. If you get lost, though, don't just silently give up. Say, Davidson, I didn't understand that. Here we go. So this is what we will do. All of these in your homework say the word added. Added reagent. If we add, where do we go every time? Away. So please look, because this can be super easy once it clicks. You find the thing the problem gives you and circle it. So it's saying, hey, we're going to add CO. So I come over here and I add CO, I circle it. And if I add, where do I always go? Away. So away means you point an arrow to the other side of this arrow. And then this answer is just the direction your arrow's pointing. So where did your arrow point? Towards the product. Okay, look at this one. I'll do one more. We add H2. So I come over here and I circle H2. If I add, where does my arrow always point? Away to the other side of the equation. So where's this arrow pointing? Towards reactants. Okay, you try 19, 20, and 21. Be careful on 21. It says O2. Please look. Please look. This says O2. Is this O2? No, it's SO2. That tricks the kids. Okay. Go and do awesome little tricks. When you get done with those three, compare it to your lab partner.
How are you today?
Oh, I'm so good.
Oh.
That's something extremely stressful in my life. It's all not react. So the stress just went with it.
You do seem like you have a little less on your shoulders today.
Well, it's because I have a little bit more down here. Because I had 2 breakfast burritos, so that helps. I don't know. They are good, but like the 1.5 $1, you're like, whoa. So that's what I said right here. Here is O2, but that's when it's SO2. Okay. Okay, wait. See if points are all out of that. So we were Billy wants into the lunch today. First thing he said, can you guess it? This is what is it? Time out! So, he thinks that right off. I could. But I'm right to his left, right where the redheaded rep is standing, literally right in front of me. He could have gone louder, that is for sure, but whatever. Okay, here we go. Raise your hands if you're done with 19, 20, 21. Awesome, here we go, my friends. Oh, that is so bright over there. If you can get it to come down, I'll be impressed. Okay, everyone besides Nico, here we go. I have Cl2, so I circle Cl2. If I add, I go away. So where's this pointing? Now she knows why I don't dare stand up. All right, good job, Emma. Everyone else that had it with that. You got to pull the string towards you and pull down at the same time.
Do you know how to play lines? Have you ever?
There you go. There you go. There you go.
She's got it.
This girl is pretty much good at every sport. I imagine she knows how to get lines down. Yeah, sometimes it draws blood. That's good. Now be careful, you have bad ankles. There you go. Okay, here we go. Number 20. SO2. I circle it. If I add, I always go where? Away. So I go towards products. O2 is just right here. If I have just O2 and I add, I go away. That's towards products. Who went 5 for 5? Raise your hand. Hey, oh, right. Okay, now, these were kind of easy because they were all added. Just watch for a second. And this, let me make sure you know what to do if we take away. You don't need to write it down. So let's pretend there was another column right here and it said remove. That says remove, okay? And so it said remove. You don't need to write this down. In fact, do not, please. Okay, here we go. If it says remove, focus with me. We would do the same thing, but this time I'm looking at these things. I put H2 in a circle. If I remove or take away, I stay. So if I remove, the arrow points to the thing I circled. And where would that be pointing? Towards the reactants. If I have H2O that I remove, I circle it. I point to it from the other side. That'd be towards reactants. I remove CO2. I take away, I stay. I stay on what side? Towards the products. Are you kind of all right with that? Add, away, take, stay. Okay, now we're going to blow through the rest of the
Beautiful.
I hate myself too. I wanted to, but remember I got cut from concert choir. Oh yeah, only never mind, someone else gets okay, the rest of the hour, we're going to study the other two things. So there are 3 things that affect equilibrium: concentration, temperature, and pressure. Patty, I appreciate it, because that's what affects reaction rates, but not this. Okay, so concentration, check mark, add, away, take, I stay. Temperature, here we go. Changes in temperature. The first thing you need to know about temperature is a reaction will be written and it will have a heat term. So it will show you where heat is given off. It might say the word heat. It might be a unit, like 15 kilocalories, or like another one like 12 joules, Joules, not the ones you use there. All right, or it might just say that the reaction is exothermic. I'm proud of you, Nico. I'll show you, I got one over there. This kid, I do not. Exothermic, if it says it's exothermic, it means heat's produced. It says endo heat over here. Okay, anyway, moving on. The way this is, it matters. So increasing the temperature, this is back on page 8. Increasing the temperature causes the equilibrium position of reaction to shift in the direction away from the heat curve. Okay. You good? So look, if I made a slight change, if I change the word increase into the word add, and then this word right here, okay, so watch right here. In one of these reactions, if it asks about temperature, it will always give you a heat term. The heat term is there. If I add heat, I go away from the heat term. That makes sense. If you are hot, do you go towards the heater? No, you go away from the heater. Right? Chemistry in the human body actually makes sense sometimes. Okay, next. Decreasing the temperature causes the equilibrium position of a reaction to shift in the direction towards the heat term. That makes sense. It's cold. Right? If you get cold, you move towards the heat, and so will the reaction. Okay. Now, I draw this beautiful picture so I can make sure you know what I mean by increasing the heat. Up here, we can't just heat the right side. What we're saying is we have some sort of vessel and a reaction is happening at a certain temperature. And at that temperature, it's reached equilibrium. Tell me now, Slade. Let's get a good run. This one, 2 years. My other one, like 15 years. It's pretty good. Oh no. Smallest power button of all time.
Oh my god.
Not three. To have two of those processes. How I can choose to do that. What is wrong?
I don't know why we do that, I'm gonna be honest.
I'm being honest, it kind of looks dumb and disrespectful. Not being rude to cheerleaders, but like usually crosses means you're lying, right?
It's double crosses though, so it
You're
cancels
like,
each other
I
out.
pledge allegiance to the right fools.
No, it's double crosses, so it cancels it out.
Oh, is that how it works?
Yeah.
Oh, I'm sorry, I didn't know double crosses rules.
It's not the rule. I thought double crosses canceled it out.
I don't really know how to function right now.
It's ready for the weekend.
I'm ready for the weekend, but spelled with all the letters, because I don't actually like the weekend.
I was really confused on where you were going with that one right now.
I'm a comedic genius. This is all on tape. You know I can. All right, it might not fit very well on this screen, but we'll just move it over here. All right, now I gotta change my share. There we go. Figure out what's going on later. Okay.
You should just constantly draw it to see it.
So you spend the rest of the day trying to draw. That'd be so fun. That's not fun. The problem is, this is when you'll notice my severe shoulder disabilities. Okay, here we go. Equilibrium, I was saying you'll reach here. Oh, that's goodness. whatever, it's already there. It's at equilibrium, you all right with that? Okay, so come back, I know it's confusing, but whatever. Whatever. We have the vessel, it is at equilibrium. Good. Thank you. I know, not please. All right, it's at equilibrium, but then I heat it or I cool it. These will change depending on where the heat term is. And we'll have new equilibrium positions. That's all we're. Okay, so here we go. If I decrease, that's like taking away. I stay on the same side as the heat term. Add, away, take, I stay. You okay with that? Okay, let's do the homework then. Oh, there's all these answers. Oh, there we go. So this time it is, well, so beautiful family right there. If this, it's on page 10, 11, 11, right? It's at the bottom, it's not the middle one. Here's what we have, it's a little different. The heat term on all of these is in kilocalories. All right? So circle everything that says kilocalorie. Everything is kilocalorie, all right? That is the heat term. Thumbs up. Jack's good. Thank you. You look a little tired. Okay. Decreasing means I take away the heat, right? So where do I go? So it stays on the same side as the heat term. What do we call this side? Reactants, products. So my answer for this one would be towards reactants. Okay, we tried 27, 8, and 9. All right. You done? You go quick. Just check your partner for 10 seconds, see if you match. 20. Okay, here we go. We have the heat term on the product side. I add heat. Where do we go if we get hot? We go away. Where's this pointing? Towards reactants. Who had that right? All right, everybody might have that right. Heck yeah. Heck yeah. Here we go. If I take away, I stay. So it's coming towards the reactant. Oh, that's getting boring. All right. Next, I decrease. So I take away, I stay on this side, which would be the switch it up on me there. All right. Now, is it? You got all of them right. Raise your hand. That kid did. Nice job. All right. Looking good. Okay, so that's heat. So far, concentration, add away, take a stay. Heat, find the heat terms, add away, take a stay. Good enough? Okay, back to the notes, and we'll be on pressure. Oh, I didn't even talk about this. Okay, so let's talk about what I mean by towards reactants or towards products. This is really helpful. Okay, so we're going to pretend that I have my two bottles. It's just this. Okay, the system's at equilibrium. Fair enough? Okay, then I come along and I disturb the equilibrium by adding reactants. If I add reactants, we all know if we add, we go where? Away. So what that would really mean, if I add reactants, the system would go towards products, right? It means it goes this way. So this is what this really means. When we say TP, it really means the following. It means the products go up. Wherever we go towards, always goes up. But the products can't go up unless what happens? Reactants have to go down. Okay. So it's important to know what we mean by TP and TR. TP means more products and less reactants. Towards reactants would mean I have more of this. So where's the water going to flow? It'll go towards the reactants. So the reactants are actually going to go up and the products are going to go down. They're always inversely related. If one side goes up, the other has to go down. They're always. Thumbs up, you okay with that? There you go. You can't have one without the other. All right, except for those points. Oh, that was a really nerdy. That was such upper level joke right there. Always makes sense. No, I mean, what? No, it's like 20 minutes to explain. It's not even fun. Nope. Okay, here we go. No, here we go. Changes in pressure. We get it? Back in the notes. Bottom page 8 still. Okay, changes in pressure. There is a word missing here.
I was like, what are we missing?
It's right here. Is that correct? Where it's missing?
Right.
Yeah.
And it's gaseous. How to spell it, but I think it's that way. Something like that. I don't know. I'm not a chemistry teacher. Why does it look wrong?
It looks like there's too many S's.
I don't know. Maybe I just felt like putting a word in there because I'm being short.
Okay, it's actually BAS.
Eraser. All right. That looks perfect. Gaseous. All right. I got roasted so hard today by the English teachers. 30 seconds for you. Today we had a meeting. It's PLCs. We're supposed to, I'm a PLC team leader. That's the way fancy name for our managing budgets. All right. We're supposed to go over like this data analysis worksheet that they shared online, and it was editable. So we get online, and I noticed the English teachers are there. So I just said, like, hello, English department. And so they replied. And at first it just said, we can't help ourselves, or something like that. What? And then they go up and put a comma after hello. I mean, it was, oh, man. I thought I was being nice, and I got roasted trying to be nice to an English teacher. Never again, my friend. Okay. Changes in pressure. Here we go. Pressure will only affect an equilibrium with an unequal number of moles of gas reactants and products. So please, when we do pressure, the first thing you have to do is add the number of moles on each side. So here we go. And we mean on the side of the arrow. So there are 3 plus 1. So there's 4 on the left. Fair enough? Then there are just 2 on the right. Now, please, there's no science reason behind this, but there's a get an A on your test reason behind it. Always circle the bigger of the 2 numbers. So 4 is bigger. Well, that was weird. My knuckle put that little line right there. Okay. So add them and always circle the bigger of the 2 numbers. Are we okay with that? All right. So we would say that the reactants has a bigger value. Okay, here we go. We'll come back to that in a second. So here we go. An increase in pressure will shift the equilibrium to the side with the least number of moles. Now, I'm gonna reword that, but you don't have to write it down. It's gonna be the same, but I want it to go the way I want it to go, because I like it when it goes the way I want it to go. All right, here we go. Can you see that line?
Yeah.
Okay. This seems cute. All right, so I have 3, I had 1, I had a 4, and a 2, right? Then I told you, just always circle the bigger of the 2 values. Okay, now I'm gonna rewrite this. I'm gonna say it. Please look at me. An increase in pressure, so if I add pressure, I will always move away from the bigger value. If I add pressure, I go away from the bigger number. So we're circling the big number because that's my generator. I'm gonna go towards it or away from it, depending on if I add or I take away. Okay, so always find the moles, circle the bigger number. And then if you add, you're gonna go away. If you take away, you're going to stay. Next. A decrease in pressure will shift the equilibrium to the side with the greater number of moles. So remember, we added, we have 4, which I circle. We had 2, which I didn't. If I take away, I stay on the same side as the bigger value. Add away, take, stay. Work with all of them, as long as you know what the generator is. Okay, homework time. All the answers. Okay, now these are the middle chunk. I don't know why they're out of order. Go ahead. So 22 to 25. You ready? So please look real quick. If there's not a number, what is the number?
1.
1. Oh, you guys are awesome. So 1 plus 5 is 6. Wow, I really like this color. 3 plus 4 is what? 7. What should I always do? Circle the bigger number. So I circle the bigger number, and then I'm going to look right here. Yes, sir. What? Good stretch. Never mind.
Yep.
Increase is the same way as saying what 3-letter word? I add pressure, so I go away, which would be force reactants.
Davidson, I understand.
Proud of you, Micah.
I'm proud of you. I'm proud of all of you. Every single one of you are amazing individuals. Okay, not all of you then. Great question. All right, what if they're equal on both sides? So do we just quit?
Yes.
That's the 2020 response, right? Yeah, we go to online school for 9 months. That's what we do. No, look. Oh, that was rude. We're at 1 case, people. We'll be fine. We got 2. We got 2. So
There's no movement.
Yeah, like 1 day.
I knocked off this word. If they're equal, their pressure has no effect. It might be an E. Sorry, we usually put not applicable.
I don't know how to spell.
Yeah, I don't know either. Ain't got nothing to do with it. That's what I read. Okay, when you have these, check with your partner. Hold on.
I got 23.
All right, here we go. I have 1, because I can. I have 2. I'm going to circle the bigger number. And then if I decrease, where do I go?
Products. I mean, stay.
Oh no.
Stay.
Oh no. I go towards the. Thank you. Super excited for that one.
I really like when you go towards the products.
How come?
I like, yeah.
I have 2, I have 1, that's 3, I have 2, that's a 2, so I've circled a 3. If I decrease, I go to the side with the big number. So I go towards reactants. And once again, if they're the same amount, there's no change, not applicable, whatever you feel like writing, no effect. It's probably not that. Okay, who got all those right? Okay, who thinks these are all not that hard? Okay, good. Turn to, no, you're right, this moment. Woo. There you go. Turn to page 9. This is the only thing we're going to do on page 9. You can cross it out 3/4 of it. We're going to do the bottom. Yep. Oh, those are beautiful. Reminds me of like what are the pancakes? The Golgi apparatus? Is that right? Or is that the ER? In 1989, kids, since I had that class. Stone Cold Jesus. Okay, here we go. Are we ready? This is slightly different. Please look. It says which one would be favored. We've been saying towards products or towards reactants. It's the same thing. You just don't need to write towards this time. Okay, so if the answer is towards reactants, just write the word reactants. They're the favored side. Now, one more warning. When you go to add the mole on each side, heat does not have a 1. Okay, heat doesn't count. It's just heat. So don't put a 1 on it. Okay, will you try the rest? Try it on your own first. Oh, that's so warm. All right, you go ahead. I would change colors.
You probably thought you were 2 different hands.
That's long. After COVID. Okay. I'm not much for bottom. Try those bottom. What? We just added into
No, it's CO2 is the rate. So it's added into the reactants.
these kids up here hanging out in the North Park.
I wasn't even there saying I knew this.
What?
Gene went to
Add away.
Right?
Double check. Yep. Yep. Now, I'm okay if you get some of these wrong, but I am not okay if you get number 7. That will be the end of our section.
Good job, Sean.
I just got that under. Amazing overseas. I love the anger some of you have when you cross out the top of page 9. I just take these all to the counselors and they tell a few people down. Like I was chill. She's like, I'm fine. Yeah, we're not, yeah, all that. Yeah. Yep, then anger. That's just either out there 24/7. Wants to real life.
last.
You volunteer. Bad idea, Fred. Okay, here we go.
I think project two.
Let's go check. First off, let me check my. Yes, you got the right answer on number 7.
Yes.
I love that. It's so glad I don't have to do them. I lost my slate. Oh,
Your slate's broken.
I know why I can't find it.
Embarrassing.
We're hiding. How about some lime green?
Yeah.
Is that green? Is that blue?
That's like.
How about that right there? That's green. That's blue. Here we go. If I add, I go away towards reactants.
We don't need to write for it.
I don't need to. That is right. I was testing you.
Yeah.
Okay, if I remove water, where do I go? Products. Does that stay? All right. The heat is added, so my heat term is right here. If I add, I go away. So that's reactants. Heat is removed. Well, that's not very hard. That's the opposite. So it's the opposite. Which side of your favorite pressure is added? So I have 5 here. I have 4 here. Circle 5.
It was a pretty bad.
That's good. All right, if we add, where do we go? Away. So that'd be towards products. Oh, Maddie. Unless it's a timeout. Then.
Oh, too soon, too soon.
No, it's too soon. Egan knows it's out of love. Here we go. And this would be the opposite, so that'd be an R. And then the answer to number 7 is no. Unless you're Sean.
I was kidding.
Okay, she's kidding. It doesn't mean the amounts are the same, it means the rates are the same. Okay, now let's knock out a ton of homework. Turn to like 30 or whatever, whatever's after the table. So page 12. There you go. Sorry, number 30. Okay. So these are not multiple choice, first off. They're not multiple choice questions. You answer each A, B, C, D.
Oh,
Trust me, it's happening.
I was all excited.
That's not what I want. Where are, there you go. Oh, no. Yeah, I have to give you a little lesson real fast on catalyst and equilibrium. You don't have to take notes, but just watch. Catalyst and equilibrium. So this is going to ask you what the catalyst does. Catalyst, if you remember the graph, it looks something like this. Then they go flat, and we say equilibrium reached it out right here. Fair enough? Okay, if I have a catalyst, I'll put that in blue. It's going to come down here and then go down there. It's going to come up here and go here. Now, it's important for you to know something. Equilibrium, it's measured by how high these are compared to each other. So we don't care if equilibrium started here or here, the equilibrium is the same. I should do this all day, except for making the shoulder. Okay, so a catalyst, my friends, a catalyst does not have any effect on equilibrium. It helps it get there faster, but it doesn't change its position. So, no change. No change. Okay, so anytime you have a catalyst question about equilibrium, you just say it doesn't do it. Now we're ready to go. Yeah, add, decrease, removal, addition, fire away. We got this. I'll do this one with you. And then I'll let you have the rest of the hour to do the rest of the homework. Yep.
Oh, yeah, because I'm not on that screen.
Yeah, I'm good. I'm tired.
Alright, here we go. So I'm gonna grease it green, I like that color. So addition, that means add CO2, add, I go away, so I'm making more product. Addition of heat. I find the heat term, it is on this side, which means it's endothermic. If I add heat, I go away towards product. Decrease in temperature, well, that's exactly the opposite. And that'd be towards the X. Oh, that's the pressure. Why am I wrong? I don't know. Just weird things happen on your own. Okay, so to understand pressure, I need to add the moles. My fault. So I have 1 and 1, that makes 2. 1 and 4, that makes 5. Probably not as good looking as 5 as before, but we're ready now. I decrease, which means I go towards the big number. So that would also be towards. No?
It's an A.
Oh, okay.
What about right?
And then O2, I'm taking it away. So that's here. I just stay on the same side. This is kind of boring. I'm sorry. I apologize. Maybe there'll be some TRs on the next. Okay, now, I'll give you time to work on the rest, but I need to help you make it 33. 33 does not give you an equation, so it doesn't mean you can't do it. You gotta write your own equation. Okay, let me take this off and beat some of it. It's not hard. Listen, 33 doesn't give you any information except for one word that's important. It is
Exothermic.
exothermic.
Oh, I'm so smart.
So look, 33, literally, just do the following. You take A, put an arrow, and put B, and then put plus heat. That's all you gotta do. And then you have your equation written. Yeah, whiners. Oh,
I'm
Well,
sorry. I did do it.
there was a lot of whining. Okay, I gotta read this email.
This is something exciting.
It's called Administrative Changes in Box Elder School District.
It's something exciting. You better share.
Nope, nothing that deals with us. All right. In case anyone cares, there's no changes that affect this school. Just glad my name wasn't in that email.
We're all like, Tom Davidson inspired effective immediate.
Yeah, you never know.
Wait, did you do something to me?
I did not, I promise. I was just joking. All right. Good. Good.
Okay, does anyone need help on number 35? Is it the same as 33? No, does it actually give you name? Yeah. Oh. So does it say it's exothermic? All right. So you're gonna have hydrogen, which is diatomic, which I'm sure all of you remember. Good. Plus iodine, which is also diatomic. Then it produces hydrogen iodide gas. You might think I'm gonna put a 2 and a 2, but then I'd be angry. Because that would be atomic. This is 35, I think, isn't it? Or is it 34? It's 35. Hey, 35A technically is words. So this is B. So A, it's all right, just put little like, whatever arrows. A would be the words, so like hydrogen plus iodide goes to hydrogen iodide. That's
That seems so pointless.
my life's work is pointless.
Just 35A. Why did you have to write it in words? You're just gonna write it in equations.
Practice, my friend. So. Let's not.
I'm ready.
I'm still trying to get my stuff from the last two. I'm not ready for another one.
So this is what I would like to ask you to do tonight. Most of you will ignore me, but one or two of you will listen. The best way to rock the test on Friday is to take all of the practice tests tonight and come to class tomorrow with questions. They're all open. Now, in class tomorrow, we will take some practice. But if you can take them in advance and think, wow, I really bombed this. I thought it was add, away, take, I stay. One, figure out what you did wrong. If we wait until Friday morning and you come in here with 20 other kids. Says it's exothermic, right? So it'd be after HI. One second, let me stop recording and then I'll be back there.